Welcome back to our classroom, and this problem is based on lens part, refraction of light. The problem is a student wants to project the image of a candle flame on the walls of school laboratory by using lens. Again read. A student wants to project the image of a candle flame on the walls of school laboratory by using a lens. They are asking some subdivision question here. Which type of lens should he use and why? Subdivision B. At what distance in terms of focal length f of the lens should he place the candle flame so as to get subdivision 1 a magnified and subdivision 2 diminished image respectively on the wall. Again read the subdivision B. At what distance in terms of focal length f of the lens should he place the candle flame so as to get subdivision 1 a magnified and subdivision 2 diminished image respectively on the wall. We need to get one magnified image as well as diminished image. For that, what should be the distance in terms of focal length we should calculate. And subdivision C, draw ray diagram to show the formation of the image in each cases. Each cases means magnified image as well as diminished image. Right? Let me solve the solution of this problem. Yes. Here we have the answer. So the subdivision A is the students should use what type of lens should he use, right? He has to use convex lens. Why convex lens? Yes. In that question they have given the students should focus the candle flame in the school laboratory wall. If you want to project, make an image on the wall, it should be a real image, right? So that we have to use convex lens. Yes? Okay. And subdivision B, when it should be magnified in the first part, and the second part when it should be a diminished image. The student should place the candle flame between F1 and 2F1. So here we have the diagram F1 and 2F1. Between F1 and 2F1, we have to place object to get a magnified image on the wall. So in that image we will get on the wall. It is magnified. Compare this object's image. This one is object. This is object. Compare with object height. The image height is enlarged, right? Therefore, we can say that magnified. It's clear. And when it should be diminished. The diminished image is obtained when the object is located at a distance greater than 2f. That means the object should be located greater than 2f. That means the left side of 2f1 of this lens. It's clear? At that time, we will get a diminished image on the wall. Yes? And third subdivision, we need to draw the ray diagram for these two conditions. For the first condition, we are using convex lens, right? And we have F1. Here we have 2F. The object is located between F1 and 2F1. So this is the object candle flame. For that candle flame, we should draw two ray diagrams. Two rays. One is passing parallel to principal axis. One is passing through optical center. If it is passing through optical center, there is no change in deviation of this light. When a ray is passing parallel to principal axis, definitely it must pass through principal focus, and these two rays are meet at this point. At that point, we will get enlarged or magnified image. Similarly, for the second condition also, we should draw the ray diagram. For that case, this is a convex lens, F1, 2F1, the object should be placed behind 2f1. Yes, greater than 2f1. So object is located is greater than 2f1. What will happen? One ray is passing through parallel to principal axis, and one more ray is passing through optical center, through its optical center. This point is optical center, the center of the convex lens. And where these two lines will meet? Yes. After that, this ray is passing parallel to principal axis. Definitely it must pass through principal focus, right? And here we have 2f2. These two rays will meet here. Now check. This is the image. This is the object. Compared to object height, image height is diminished, right? Strict, right? That's why we are getting a distance greater than 2f1 or beyond 2f. I hope you understand well. Thank you. See you in the next video.